Today we're going to work on Chapter 7, Section 4 on similar triangles. We're going to cover two new postulates, the side-side-side postulate and the side-angle-side postulate, which are ways of telling that triangles are similar without having to compare all the angles and all the sides. Okay, make sure you have your video worksheet out. Notice the first few problems are just openers. I'm going to leave those for you to complete on your own, but I would like to do the terms, definitions, and diagrams section with you. This is the new material. Okay, we're going to start with the side-angle-side postulate. What that means is that if two sides of one triangle are proportional to two sides of another triangle, and the included angle of the first triangle is congruent to included angle of the other triangle, the triangles are similar. Okay, we can go ahead and fill that in. Okay, so two sides of one triangle are proportional to two sides of the other, and the included angle of the first triangle is congruent to an included angle of the other triangle. That's enough to show the triangles are similar. Okay, I'm going to draw the situation of the given triangles to show you what I mean. Say this triangle has a side length of 5 and a side length of 11. And the angle here is maybe 20 degrees. Okay, the other triangle has a side length of 10 and a side length of 22. And the angle is also 20 degrees. So I'm going to put the arc to show that they're congruent. Okay, notice that the two angles are congruent to each other, as in they both have the same measure, and then the sides are proportional because the ratio of 5/10 is the same as the ratio of the 11/22. Both of them reduced to be 1/2. Okay, that's enough to show that the triangles are similar by side-angle-side postulate. And I'm going to write the similarity statement as well. Triangle ABC is similar to triangle XYZ by side-angle-side. The next postulate we're going to cover is the side-side-side postulate. Okay, and that's at the bottom. It says side-side-side. Each side in the first triangle is proportional to the corresponding side in another triangle. Okay, so you want to fill in proportional to the corresponding side in another triangle. What that means is that the ratio of the pairs of corresponding sides all simplify to be the same fraction. Okay, so I'm going to give you some numbers to label and then show you that they're proportional. So say ABC is like a 4, 6, 8, and then XYZ is 12, 18, 24. Okay, I need to compare those sides and see if the fractions simplify to be the same. Okay, my recommendation is always pick the two smallest sides that go together, the two middle sides are corresponding, and then the two largest sides are corresponding. So the smallest side of ABC is 4. The smallest side of XYZ is 12. The smallest, or the largest side of ABC, that's 8. And that's got to go with the largest side of XYZ, which is 24. And then the middle pair of sides would be 6 and 18. Okay. In order to see if these are proportional, I want to reduce each fraction and make sure they turn out to be the same thing. So like 4/12, both those are divisible by 4. Simplifies to be 1/3. 8/24, both those are divisible by 8. Simplifies to be 1/3. And the last one, 6/18, both those are divisible by 6. Turns out to be 1/3. Because all of those are the same, that means the ratios of corresponding sides are proportional. And all I need to do is write triangle ABC, similar to triangle XYZ, by side-side-side. And we've got two more examples at the bottom of the page that we've got to work through. Notice neither of them have marks on them. I'm going to give you the numbers that we fill in, and then we can work out the problems together. So for number 1, in order to do that problem, you need to mark on the first triangle 6, 12, 9. And on the second triangle, you should mark 8, 16, 12. Okay, the question is, are the two triangles similar? If so, write a similarity statement. Now we've really only covered a few similarity postulates: side, angle, side, 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 angle, angle. Based on looking at this triangle, the one that might apply best is side, side, side. And the reason is because all the sides in the picture are labeled. Okay. In order to have side, side, side similarity, you need to make sure that the corresponding sides are proportional. So I'm going to compare the sides, see if the fractions are all reduced to the same thing, and if they do, that's what tells me the triangles are similar. The smallest side on the left triangle is 6. The smallest side on the right triangle is 8. The smallest side, or the middle side on the left triangle is 9. And the middle side on the right triangle is 12. And then the biggest side on the left triangle is 12. And the biggest side on the right triangle is 16. Okay, from here, all I have to do is reduce those three fractions, see what they are. 6 over 8, those are both divisible by 2. So that's going to make 3 over 4. 9 and 12, both divisible by 3. That's going to make 3 over 4. And then 12 over 16, both divisible by 4. That makes 3 over 4. So in this case, since all those fractions simplified out to be the same thing, the answer is yes, the triangles are similar. And then you'd say triangle ABC similar to triangle XYZ. Okay. Last problem. Again, you need a couple marks on here to figure out what goes with what. I'm going to give you this side is 50, this side is 60, this side is 70, this side is 84. Okay, you should recognize on your own that since there's vertical angles in this picture, you can also mark those two angles congruent to each other. And then you have to decide which similarity statement best fits the situation. What I see is two pairs of sides and the angle that's included between them. That looks like side angle side. To make sure, I've got to compare the sides and see if they're proportional. So I've got the angles already. The smallest side on the left triangle is 50. Compared to the smallest side on the right triangle, which is 70. The biggest side on the left triangle is 60, and the biggest side on the right triangle is 84. Now it doesn't matter what the third side is because we're not going to use it for this application. Okay, all we've got to do at this point is figure out if those two fractions are the same. Okay, one way to do it is just simplify both sides, like 50 over 70. I can cancel out 10, so I get 5 over 7. 84 and 60 are both divisible by 12. And that simplifies out to be 5 over 7 as well. So in this case, those triangles are similar. I can write the similarity statement. I'm going to write yes by side angle side similarity. Triangle SGM is similar to triangle. Now I've got to be careful. I've got to make sure I list the letters in the right order. If I did SGM on the first one, second one has to be LVM. Okay, and that's side angle side and side similarity. See you in class.